Hello, good morning, good afternoon, everyone, and welcome to today's webcast on Databricks for data science. Today we'll be focusing on experimentation to productionization. So a quick overview of today's agenda. We will be starting with a quick introduction of Thorogood and an overview of Databricks. Then we'll move on to experimentation to productionization and how Databricks fits in with a few demos. And finally, we'll close with a few key takeaways. So starting with introduction of ourselves. So hi, I'm Deepika Bhatt. I'm a data and analytics consultant with Thorogood Associates. Along with me, I also have my colleague who will be presenting with me today. Starting with a quick overview of Thorogood. For those of you who are not familiar with us, we are an independent business intelligence and analytics specialist consultancy with operations in the US, UK, India, Brazil, and Singapore. Our core business is the design and development of business intelligence and analytics applications, but we also provide a full range of services, including strategies and roadmaps, training and user adoption, and support and data services as well. We are an independent professional services consulting firm, and we work with a wide range of tools and technologies. And obviously, as you can see, Databricks is an important partner for us, and we're talking through their platform and offerings today. Typically, we work in data-rich verticals such as consumer goods, pharmaceuticals, financial services, including insurance, mining, and shipping. Some of our customers listed on this slide here. To begin with, what is Databricks? Databricks comes from the creators of Apache Spark, an open source platform that is used for big data engineering and large analytics workloads. Databricks was founded as a private company to build upon the Spark foundation and enhance it for enterprise organizations' use. They've created the Databricks service, as they aptly refer to it as Unified Analytics Platform. The Databricks platform sits on major clouds including Azure, AWS, and GCP. Its notebooks can also be authored in a variety of the most popular languages used by data scientists, engineers, and analysts alike. So as you can see here, SQL, Scala, R, and Python. And we also see a flavor of that in today's demos. As it's a cloud platform, it's very effective at auto-scaling. It can manage your compute for you, and with the new serverless versions in flight, this becomes even easier. It also now comes complete with a compelling operational data governance tool to help manage all of our Databricks assets as well. Beyond this, certainly in our opinion, it is best-in-class tool for data engineering at scale, integrating with native data lakes, but also offering an open-source Delta Lake project. On the data science side, it comes with a lot of libraries and packages pre-installed. In addition to that, it comes equipped with MLflow. What is MLflow? MLflow is an open-source platform created by Databricks for end-to-end machine learning lifecycle, and we'll see a lot of that in today's demos as well. So looking at this overall, it's fair to say that with all these capabilities, we are seeing Databricks being a key component of effective cloud data architectures. In today's session, we'll be focusing more on the data science aspects. So if you'd like to learn more about the fundamental concepts of Databricks, do check out our pre-recorded content and also upcoming hands-on workshops if you'd like to learn more. Starting on the topic for today. So before we get into how Databricks platform fits in, I wanted to start a bit with giving you an overview of what a data science project looks like. What I've drawn here is a cycle, and that's exactly how a data science project or initiative would work. Starting with definition of a use case, experimenting, and trying to engineer what model works best for us. And then moving on to thinking about productionizing it, deploying it, and then using it to make predictions. And it doesn't really end there. You would want to continue to monitor and improve the health of your models over time as well. So the key thing being machine learning is a life cycle. It doesn't really end at industrialization or even at monitoring. It's important to understand this cycle because it defines how an entire data science initiative should be structured. For example, who are the people who should be involved at these different stages? What capability and skill sets are needed for this? But even more critical is the fact that this will define the choice of tools and platform that you ultimately decide to use. We see that productionization or industrialization is an afterthought when people start with data science initiatives. So it's important to think about it not just in silos, but to be able to ensure that you're thinking about all of these aspects when you're setting up your platform so that you can realize your ultimate vision. With that, I'm going to hand over to Brendan, who will talk a bit more about how Databricks fits into this life cycle.
We'll talk about the road from experimentation to productionization and how Databricks can enable it. So when we think about what Databricks offers from a data science tooling perspective, we can break it down to generally three different parts from beginning to end. We can think of this tooling and this breakdown as a subset of the MLOps lifecycle that Deepika has just mentioned. It's really all part of the same spectrum, and it really begins with some sort of data exploration, the experimentation with that data, and ultimately the productionization or operationalizing of that experiment to produce tangible insights that can deliver value for the business. And in many organizations, we can see that a lot of these activities that fall into these different buckets usually use different tooling and softwares across a variety of different vendors. And the compatibility between them is just another complexity that's ultimately rolled into the project lifecycle that can be avoided with a tool like Databricks. And while this webinar is really just limited to the data science capabilities and features that Databricks offers, you're remiss without mentioning the impact that Databricks can have on traditional data engineering workloads and general data curation. Coupling that capability with everything that we'll be speaking about in more detail today speaks to the further blending of the lines that we're seeing emerge between data engineering and data science. Our intention for this webinar is to introduce some key features of Databricks that fall into each of these buckets by first introducing them and then diving right into the tool itself. But before we get into that tool, let's talk a little bit about the demo and the data set for which we'll be working with today. The data set in which we're exploring has thousands of different tracks from Spotify. So I put a few of the more notable ones up here, such as tempo, the beats per minute of a track, loudness, which is the overall loudness of a track in decibels, energy, which is a perceptual measure that really measures intensity and activity of a given track. So think of the difference between something like heavy metal and Beethoven, on opposite ends of the spectrum, and duration, or the length of the track in milliseconds. So we'll use these features and many more to ultimately predict how popular a track is perceived as, which is due in part to the number of plays a track may have and how recent those plays are. But really, before we can experiment, we of course need to explore the data, and Databricks allows us to do just that. So let's talk about some of those features. Databricks does make exploring data quite easily. It allows you to navigate through all different types of data that may be stored. Using Databricks too is language agnostic, as Deepika had mentioned. So data scientists, engineers, and data analysts alike can use SQL, Python, R, or Scala to analyze data within the tool. This flexibility of languages really allows for ease of querying, irrespective of what a user may be most familiar with. And within Databricks too, everything is really convenient in that the editor is very navigable and contains many of the features that we'll be sharing today all in one place within your web browser within the Databricks workspace. That includes the inherent visualizations within Databricks as well, which we'll also show in a moment. Users can read in data from wherever their source may lie, as I've just mentioned, display a data frame or materialize a table based off some code that they may have written, and immediately show a visual for ease of analysis. A lot of the time, a user may write queries and output the results into another data visualization tool to perform exploration. That's really not needed within Databricks. Within the same editor in which you've just written your query, you're going to be able to have a visualization right up against it. Lastly, we have the data profiler. So the data profiler is very useful in enabling users to understand distributions of data and other summary statistics, various columns within their data frame or table. It's really a great way to see if you're dealing with some outliers or you're dealing with strange patterns. Really, either way, data profiler can facilitate a much deeper dive of your data. Let's get right into Databricks here. So the first notebook that I'm going to share here is just to explore some of my data here. So the first thing I'm going to be doing just reading in some of my data from my data lake. Within this data set, obviously, there are a lot of columns here, so just sort of see what it looks like within the profiler. I'm going to filter things down just a little bit. Within our profiler, it's very easy to add it. I've added it just for demonstration purposes here, but with the touch of a button, I can just create a new data profiler that would effectively do exactly what I have on the screen here. So just by looking at this data profiler, we can see a bunch of summary statistics, and we can see the distributions of our data as well. And immediately, we can come to the conclusion that something is going wrong with duration meters per second, or milliseconds within our data set. We can see that our max value is 5.24 million milliseconds, which is actually around 87 minutes. So when it comes to maybe determining the popularity of a track, that could be seen as an outlier. And same thing, something strange is happening with energy as well. So just by having this data profile here, I can immediately understand maybe some outliers within my data set, and then I can subsequently just filter them out, as I've done with this command here. And we can see that the distributions are looking much better and much more realistic as to what we would expect them to be, within the context of our data set. And additionally, too, if I wanted to drill in a little bit deeper, I could expand these visuals, expand these distributions to really get a sense as to what the data is actually telling me, all again within the actual editor itself. I mentioned the compatibility within using other languages within Databricks too. So I was just using a lot of Python just to create that data frame and to do a lot of exploration. But within the context of this Python notebook, I also have the ability to flip in between using something like SQL, R, or Scala as well. And I can just do that by indicating as such and then running the command soon thereafter. So as we can see here, not only can I create a profile or a data profile with the touch of a button, but I can also create another visualization. So you can kind of see an example here of a scatter plot showing popularity and tempo, then sort of grouped by the track genre. Now, for example, if I wanted to say edit this visualization, it wasn't doing everything that I really wanted it to do, I could bring in additional information, I could group by other descriptive columns, and I could even create many other visualizations here that Databricks has to offer. Again, all within the context of the same querying and analysis that I may be doing with other exploration that is sort of happening. Just to show a couple more examples here, we can see just another histogram, and then we can see a box plot as well, just to show you some of the visual capabilities that Databricks has to offer. But I think the main thing to share here is that, it's all available to you right with the code in which you're writing. You can materialize things immediately. So that will sort of do it from an exploration perspective. But, we'll say at this point, I'm very satisfied with the data in which I explored, and now I'm ready and willing to experiment with it. So that brings us to our second phase of experimentation. And we'll begin with the concept of feature stores and how they're enabled within Databricks. So a feature store is effectively a centralized repository for data scientists to store features. Machine learning experimentation will really use data, obviously, to build models to predict future outcomes. And in nearly all of those cases, as we've just seen, data needs to be pre-processed and transformed before it can be used to build a model. Through this process called feature engineering, we can generate and save our features so that we can use it for our own experiments later. Now, developing features is complex and time-consuming. These calculations for features need to be done for model training, and then again for when the model is used to make predictions. By performing these calculations once and storing them within this feature store, we can save time for ourselves as data scientists and allow others within our organization to use the features we have engineered for their own experimentation. It also ensures that everyone is utilizing the same features for their modeling. It all ultimately becomes very auditable and ensures consistency across their different experiments. Within the context of experimentation, I'll also talk about the model tracking aspect of MLflow, and Deepika will touch a bit upon the others that relate to productionization and operationalization of your experiments. So MLflow is the open source platform for the end-to-end machine learning lifecycle that's been developed by Databricks and comes pre-installed on Databricks ML runtimes. MLflow tracking is the programmatic reporting and querying of these experiments, which includes artifacts, data, evaluation metrics, and more that define what an experiment actually is. So MLflow has a ton of inbuilt libraries with functions that make all of this tracking all very easy. And finally, we have AutoML. And AutoML will allow you to rapidly generate models, the code that sits beneath it, and to really just give you a jump start on your experimentation if you're not quite sure where to go initially. Because the code is essentially laid out for you, which we'll show in the demo, gives you a head start on the tuning that may need to be done to make, say, an AutoML generated model even better. So we'll now head back on over to Databricks, where we'll talk through feature stores, some experiment tracking with MLflow, and a quick demo of AutoML as well. Just as I've done previously, I'm going to read in my demo data and pre-process it as I've just done, because I want to clean my data so that it's prepared to go into the feature store. But in addition to just some of the pre-processing that I may do, I may want to create some features that I can also be using for my own experimentation. Now, these two features are obviously quite simple with respect to complexity and also just computation. But imagine if I was trying to create a feature that is much more computationally intensive than this, over millions upon millions of rows, whereas this data set is relatively small. We'd obviously want to be able to do that just once so others can use it and ultimately save time and effort in not having to repeat work that I may have done. It's all very simple, really beyond that. I have my data frame for which I will be creating, and then I can write all that data out directly to the feature store within Databricks. I mentioned the workspace being very navigable. So just by the click of a button, right, I'm immediately able to just bring myself right to this feature store tab where I can explore some other information within the user interface. And we can see a bunch of information about it as well to, again, help with that auditability and to really understand what kind of data is going to be existing for use within my experimentation. I can see when something was modified. I can see a description. I can see any tags I could have added. But maybe most interestingly, or I can see a lot of my features too, obviously, as I would want to make sure that I can see what I'm working with in the feature store. But when we're speaking about auditability as well, I also have the ability to see the exact notebook version that was actually used to create this table within my feature store. So again, really helping with the auditability. So others that may not be as familiar with what was done to create said features would be able to grab them for their own use and really understand how they were created and how they were curated. But now that I have everything created in the feature store, I may want to ultimately experiment with it, right, to actually build out some models. But before I really get to that, just to kind of illustrate the compatibility between what's available within the editor, what's available within the UI, we can clearly see here that I'm able to query directly against the feature store that I was just showing within the UI to show some key information on it. Again, just if someone may be more comfortable or wants to just query something programmatically as opposed to using the UI, they do have the ability to do so. Let's get back to our experimentation, however. So as I mentioned, our experiment is to really predict the popularity of a track based on many different features that will sort of be passing in from this data set, which is ultimately coming from a feature store now. And to do that, I, of course, will first need to create my train test split. And for this experiment, I have a general sense of where I want to go. I have 3 different regression models that I'm interested in running. That would be a linear regression, XGBoost, and a random forest model, right? So within each of these models, I will effectively be logging various things that I can ultimately access within MLflow. And when I talk about, different models that I want to experiment with, I'm ultimately going to want to elevate one of these to production, which is one thing that Deepika will touch upon within her demo as well. But as I sort of run these different cells within Databricks, we'll notice that this will sort of pop up near the bottom of the cell saying a run has been logged to an experiment with MLflow. So I'm just going to follow this link here. And we can see that within all these different models for which I've just run, I can get a lot of important information that can really tell me a lot about the model and some of the different information that's sort of associated with it. I can see the parameters, including my features and my label, any evaluation metrics that I would have wanted to collect as part of that model running as well, any tags and the artifacts too. But of course, as I mentioned, we're interested in elevating a model to production. And in this case, our best model can be perceived as the one with the lowest RMSE. And in that case, that happens to be our random forest model, which can be clearly seen within the UI here, just by comparing it within this chart view. So very easy. You have many different runs to see which one may be performing best based off of an evaluation metric if you're choosing. But I don't need to just do it within the UI as well. I can also, again, achieve that same information programmatically too within the editor as well. So just by establishing the experiment ID, I can query against it and materialize this data frame. And then I can also display, some of my best runs to really understand that and be confident in that my best model, based off our experimentation here, is the random forest model. That's with the understanding that I really knew the 3 models that I was interested in testing. If I wanted to say get a jump start on my experimentation, I'll use something like AutoML, right? So with AutoML, as I mentioned, it'll really allow you to jumpstart your experimentation if you're not quite sure where to begin. And similarly, as I've just done with my other experimentation, I'm going to create my train test dataset, and then I'm simply going to log an AutoML experiment. And similar to that, this will be logged within MLflow, and we'll see a few different hyperlinks for which I'll follow just to kind of show what will sort of materialize from this AutoML experiment. So we can see that just by using that one simple cell, 66 models were actually produced, all with different sorts of inputs and variations that will really give us a good jumping off point for further experimentation. So I can clearly see that this XGBoost model that was produced is our best. It's our best performing. And I can see all the different parameters, the metrics, the tags, the artifacts, as I just kind of illustrated with your other notebook here. And not only will it just display the actual metrics that are sort of associated with it too, but it will also actually produce the notebook that will be used to produce this best model. So Databricks will do that all automatically. As I mentioned, will serve as a really good jumping off point for an individual that is maybe not quite sure where to turn with their experimentation, but wants to just start somewhere. And you can then take this notebook, really understand what's going on, and maybe even tune it for further purposes as well. So just kind of just scroll through all the different things that it kind of does all of this again automatically. With that all being said, that will kind of handle it from an experimentation perspective. I'll now turn it back over to Deepika to bring things to a close with some productionization features that Databricks offers.
So now that we have looked at the experimentation aspects, the next step for me as a Brendan's colleague, for example, who is looking to productionize this model and scale it to my organization, I need to think about how am I going to do that. In the last phase, which is quite critical for this spectrum, is productionization. So as Brendan spoke about MLflow, in addition to tracking of experiments that is inherent to MLflow, we also have the ability to package, deploy, and register our models. We can then manage their life cycle from staging to production, and then if we need to archive something, all of that can be managed within that interface. The model registry gives us a centralized view of all our models, the different versions, the permutations between them, and the runs that actually produce the best model. And more of that we'll also be looking at in demo shortly. Once we have registered a model, we also can start using it for scoring. What does that mean? So once, for example, we have some new songs that are going to be listed on Spotify, and if we wanted to predict their popularity, rather than having to recreate the model, we can just use the existing model that we have deployed and impute those results. And finally, to ensure the ongoing health of our model in a production environment, Databricks also allows us to set up custom logging, some of which we saw in Brendan's code, where he was logging RMSE, R2, and different accuracy metrics. We can continue to do that for our productionized models and ensuring that we are continuing to improve them over time. So not spending too much time on slides, I will move on to the productionization demo. So in this case, as we said, it's a unified platform. I can look at what is the experimentation work that Brendan has already done, can look at what the best performing model was, in this case, a random forest model, and I can start working on productionizing it. So looking at that, again, importing the MLflow library, which comes inbuilt with the Databricks platform, the machine learning cluster, import the relevant libraries and the MLflow client, and I can start working on packaging that, deploying that, and registering the model. So in this case, picking the right experiment that produced the best result, and then using this command essentially to register the model. So as you can see, I'm able to do all of that programmatically. In addition to just registering the model, I can also add additional metadata, for example, the description for the model, adding what stage I want to log it as within the code. And if you're partial to a more graphical user interface, we can also look at the registered model in this tab, which is named as appropriately as models. So when I go in here, as you can see, I have the random forest model that I just deployed. Considering it's still under testing, I've put it at a stage which is named as staging. But in case I'm happy with the outcome of it, within the interface graphically as well, I can transition it to production and add relevant commentary. So as you can see, it has that sort of Git integration where you can see the different versions of the models. You can look at who were the last person who worked on it and what were the exact metrics captured as a part of it. So that's essentially regarding the packaging, deploying, and registering of the model. Now that I've registered this model, the next activity is being able to actually serve this model and use it for scoring. So as you can see, within the same interface, I have created a model serving notebook. What I'm trying to do here is create a batch prediction or an offline prediction using the registered model. As you can see here, I'm calling the same random forest model that we have just registered using the productionized version of the model and then loading that into this notebook here using a few commands. So I'm not going to go in line by line, but focusing on the key aspect here. So this is essentially the MLflow function that I'm using to load the model into this notebook. So for just using the model, I don't need to know anything more. I can just load the model in and use it for my computation. I've loaded some new input song and ultimately run this model to create a predicted popularity table. So looking at our existing features that Brendan mentioned, I've used that for the new tracks and then ultimately predicted the popularity. So not just being able to register and then also able to use it within the same platform. And finally, if you're interested in serving it from an external platform outside of the Databricks environment, you can also create serving endpoints. So in this case, I can, with the latest version of my model, call it music popularity and create that as an endpoint. So using this link, I can also go into and create to an external endpoint and use this model for a serving purpose. With that demo, we've already seen how Databricks can integrate all of these things end to end. So coming to the key takeaways, flashing back up the machine learning lifecycle, as we have seen, as any data science initiative, it doesn't just really end at industrialization. It doesn't really end at experimentation. We need to think of it as a complete cycle. The gap between investment and actual realized benefit is caused in a large part because people have been thinking about these as two separate activities, whether it's experiments or productionizing it. That's where MLOps really comes into the picture. So machine learning operations refers to the practices for orchestrating the development, deployment, and maintenance of machine learning models in a scalable and standardized way. MLOps really is necessary to enable the organizations to be able to fully realize the benefit of ML at scale, responsibly, and also being accurate. And as we have seen today, Databricks really understands that, and they have created a platform where you can not just do experimentation, but also cover all the other aspects of the machine learning lifecycle. Why is MLOps are necessary in your organization? To be able to increase the accuracy, ensure your users are empowered to, not just create experiments, but also ensure that they're getting the value out of it. And as we can see, you can also manage costs effectively if all of that is within the same tool set. And how can Thorogood help you with this? At Thorogood, we have experience in strategizing and implementing MLOps frameworks at the organization level. Having a baseline of where your organization is currently from an MLOps perspective is a huge place to start. And once you have that understanding, you can address those challenges. So if you're interested to learn more on how we can help you with MLOps frameworks, do get in touch with us. And with that, we come to end of today's webinar. Thank you very much for joining us today and have a good rest of the day.